Hello, good day to everyone, and welcome you to the another episode on Autodesk Moldflow tips and workflow or the improvements. Particularly in this episode, I'm going to talk about the enhancements and feature capabilities, that's been added into the Autodesk Moldflow 2023. This episode is in continuation to the earlier episode that I put in for the way the installation has been and introduction of the named user to the audience completely new for this episode. My name is Sachin Fulsundar. I am a senior technical specialist, part of the advanced manufacturing group at Autodesk. With that, probably I want to talk for like in a few seconds on the event, particularly our incident that happened with me in this week. And I was working on a quite complex model. When I say complex, of course, it comes to the mind that uh, part with a multiple features and thickness variables. Well, I was working on a part which was having a lot of holes actually, and some were blind holes and some were through holes on this. And yes, you understand correctly. I was working on a speaker grill, and you know that how much time it takes for creating the mesh and running the analysis. Can I able to get some answer for these type of analysis or analyzing this part in these announcements? Probably yes. So let's get started and see whether I'm able to get some answers to analyze these complex geometries. With that, I like to get started with the three areas that Autodesk division always been focusing on is the market impact that talks about the way we are doing the installation, the ease of use, and the simplification of the licensing and the introduction of the mold flows named user. We're going to talk on to the today's episode on to the productivity and workflow enhancements that we are going to talk about like in something on shrinkage compensation improvement, introduction of the 3D grill element, and something that connects to my earlier discussion, the problem that I mentioned you. And there is a whole lot of improvements into the solver technologies. Thank you for keeping a trust on to the technology and being a vocal and participating in giving the feedback. Your feedback is always been heard by the development team, and they try to put it. And that's give a chance to talk about my next episode. That is something on I want to work upon is the Scandium technology. So in today's episode, we are going to discuss on the productivity and the accuracy improvements in terms of the solver. That let's talk about the user interface improvements. I would be little, running faster to get everything captured in that time or the 10 minutes or 15 minutes of the this time. So probably want to start with the user enhancements or the interface experience or the user experience on using the uh, software is start with a shrinkage compensation. If you've been using a Moldflow from version 2019 and earlier, and you would definitely tried using a shrinkage compensation after doing an warp analysis. And we would have noticed that earlier versions, I would like to talk about like a three versions earlier, shrinkage compensation was applied to the entire space that you see, including the distance between the cavity, and that was creating a bit of accuracy challenges to it. And the feedback was given to the development team. And with the version 2021.2, we did an enhancements in terms of applying the shrinkage only to the visible cavities. So if you have whatever the cavity that you are visible onto the multiple cavities, the shrinkage compensation was getting applied. But with the 2023 release, now the shrinkage compensation is being applied individually to all the cavities. So rather than what you see on the screen, you get supplied to the individual cavities, and that makes much better sense than just applying it to the cavities which are visible. There's enhancements into the meshing speed, and I have noticed I tried doing it into the earlier versions and today's version or 2023, and I would see there's quite a better enhancement. And with that brings out the announcement for the advisor 2021.2 versus advisor 2023 is that we are trying to apply a same algorithm or the meshing as that been used for the insight. So it fixed the problem of the bad mesh structures or the fine surface mesh that was occurring into the advisor 2021 point, uh, and that gets rectified with that. So same algorithm is being used for the advisor, what we see into the insight now. And as you try to increase the resolution of the mesh or the model processing resolution, you can see a refinement coming up into the models. So give a try for the advisors user, or many times I've seen the users importing the insight file into the advisors to get a better mesh accuracy or the representation of the model. Let's look at into the solver improvement. And the first improvement that I want to talk about is more onto the accuracy in terms of the how we represent the 3D fiber orientations or the 3D model fiber orientation in 3D model, I would say. And this is for the discrete fiber or short fibers, and shows the comparison. The graph onto the left hand side shows a comparison between the 2021.2 versus 2023 point, and the advancement that we have done uh, is more like the core is getting more strongly represented in this release actually, and that gets much closer to the actual data versus the earlier version. So the core may be having a little broader now, and it has gone to the deeper versus the earlier version. That gets closer. I would not say that exactly closer, but now the core is a little deeper versus the wider as compared to the earlier version. And the effect is more prominent for the long last fiber. Um, and you can see on your right hand side of the screen the thicker junkier parts, uh, which shows the core. In actual, the core is represented by the wallet curve, and the curve with the green is the current versions. And you can see that the core has been little broader. Well, there is no change happening onto the shell area. It just remains the same. But when it comes to the core, or the transverse direction, I would say it's more strongly represented, and it's more like a wider core is been formed. Again, it is getting closer to the actual experimental value, not exactly replicating to the but very much resembling close to the actual. And that gets back me to the event or the incidents that I started with it, how we represent the complex grill model or the models that are having a repetitive type of features. So the one of the announcement is like assigning the grill element attributes to the simplified model and capturing the effect onto the your filling pattern, the pressure, temperature, frozen layer, fiber orientation, and warp. Let me put it in this way. Now, the model that you see on your right hand side of the screen, extreme right hand side, it has a lot of features, the holes, through holes. And the middle model that you see is a simplified model where I have removed all these holes, and the elements has been selected in that area, and the grill element attributes has been assigned. Now the model preparation has come down significantly. Less number of elements are needed to represent the model. And the most important thing is that I am reducing down the computation time for this particular model 6 hours versus the 10 minutes. How faster I can do the iteration of changes in the model and get that required results for that. And same I could able to replicate for the pressure effect, because Filling pattern is one of the thing, as well as the pressure should also be represented, because these two things will have a direct impact on to the your work results. And I can say that I'm very close to the what the actual full model will represent versus the simplified model. This was the most complex model that the development team has could able to choose, and they run it at their end and were able to come out with the results. How do we go about and assign those 3D grill element? Well, if you have a simplified model ready, select the elements and change the properties. By default, all of the 3D elements will have a cross-section shape, which I have highlighted over here as a flat. From the flat, you need to select as a grill with the holes, or the grill with the round holes, or probably square holes, or the another factor is also available. It's like altogether which cannot be a square or round, that holes also can be presented. What parameters you need to present enter is whether your holes are blind or through. What is the depth if it is a blind hole? Distance between the holes. I'm talking about the edge to edge distance, not the center to center. Enter the diameter of the hole, the shape factor for imperfection. Like, take an example. If you have a square, all the holes, but I could not able to represent the square properly in the mesh, so that increases the imperfection. So if your imperfection is increasing, try to put the value more than 1. And this is an experimental or the comparison between a full model. The model without the holes is just like in a plate with no holes, and just meshed it, and now I have assigned the grill properties to it. If you've been using a Moldflow for some time, probably for the mid-plane elements, we used to assign something called a shape factor. Well, new 3D grill element attributes is the shape factor, very similar to that for the 3D model, because this was been asked by the many of the users that the like the mid plane we have a simplification of doing or representing model. Why can't we get it for the 3D? We tried to put the same approach for the 3D elements as well. Another solver improvement is into the 3D sync mark predictions. We've been consistently working on improving the results. From 2019, we were not able to predict the sync marks at the chunkier section. It needs only like an rib, and opposite to rib only we were able to represent the sync marks. But from 2021 and onwards, 2021.2 and now 2020, the sigmark representation or the predictions has improved significantly, not only in the rib area, but also into the areas which are chunkier, which has a high thermal drops or the hotspots. We could able to predict the sigmarks much better. Another representation improvement, it would be say a cool BEM improvement. What does it mean? That in earlier version, wherever there was a cooling line close to the part, or the mm, beam elements close to the part, like you see on your left hand side of the screen, it will create like a cold spots or the hot spots, and that effect has been now nullified or improved into the mold flows inside 2023. Another solver improvement is in the mid-plane injection compression. The way we represent the cavity thickness in for the mid-plane has been actually been implemented for the 3D models as well. And that takes me to the the that's all I would say we have it for the this episode. For the next episode, I would like to take you through the Scandium Tech Preview 2023 updates. So stay tuned and let me know your feedback, what you like about the enhancements or the features improvement. There are a whole lot of enhancements that are available, and I would say that you should refer it to the what's new page available, and that talks about the solver enhancement, the mesh enhancement, the database that's been added, and also the simulation compute manager updates. So have a look at and go into the details if you are interested to know the each and every bit of it. With that, thank you for your time and talk to you again.